Now we're going to take a look at lesson 62 after you have finished the investigation. Since not all functions can be written explicitly with y isolated, we are going to look at implicit differentiation, which allows us to take the derivative of functions that cannot have the y variable isolated easily. Starting with example 1. If x squared plus y squared is equal to 25, let's find dy by dx. So here we can pretend that we are just differentiating with respect to x as usual. So x squared, derivative is 2x. Plus, now y is not a function of x yet, so we have to remember we have to apply chain rule, differentiate y squared, y, and chain rule says that this is dy by dx because we still have to differentiate with respect to x equals to 0. And then we can isolate for dy over dx. Well, first we're going to take 2x to the other side of the equation. And we know that after that we can divide the result by 2y. And dy by dx is negative x over y. This particular function can actually be written with y isolated relatively easily. So let's consider y squared equals 25 minus x squared. Y is plus or minus the square root of 25 minus x squared. Let's take the derivative of y here. So this is really 1/2 of 25 minus x squared, and then take the derivative of negative x squared, which is negative 2x. And since y squared is 25 minus x squared, which is in the denominator here, y prime is still negative 2x over 2 times y, which is the same as what we got when we differentiated implicitly y over x over y negative. Okay. Example 2. We have x times y equals to 12. Let's try to differentiate this implicitly using the chain rule or the product rule. So the derivative of x is 1, y stays the same, plus x stays the same. Derivative of y is dy by dx equals to 0. dy by dx then would be negative y over x. B, we have xy squared equals to 24. You can pause the video now to try this question before looking at the solution. Assuming that you have tried question B, here is how I would differentiate this particular equation or expression using implicit derivatives. Using implicit differentiation. Derivative of x is 1, y squared stays the same, plus x times 2y dy by dx equals to 0. dy by dx is negative y squared over 2xy. I can simplify this into negative of y over 2x. Let's try question C. We have a trinomial. We can take the derivative term by term. First term, 4x cubed. Plus the second term is xy. Derivative of x is 1 times y plus x times the derivative of y, dy by dx. Plus 4y cubed, and don't forget chain rule, dy by dx equals 0. Okay. I'm going to group the terms with dy by dx, x plus 4y cubed, and move the other terms to the right side and get dy by dx is equal to negative 4x cubed minus y over x plus 4y cubed. Just like that. Example 3. Find the slope of the tangent through this function at the point 1 and 2. Right away, we can tell that this function is way too complicated for us to try and isolate y. Doesn't seem possible. As a result, I'm just going to use implicit differentiation in order to find the first derivative and then use that to find the slope of the tangent. Let's begin. 3y squared dy by dx because of chain rule minus 3xy squared. I need to use the product rule. This gives me 3y squared plus derivative of y squared is 2y, so 6xy dy by dx plus x squared y, using product rule again. I have 2xy plus x squared dy by dx. And then we have plus x squared, so that's 2x equals 0. Okay. Next, let's gather all the terms that contain dy by dx, and I will factor that. I have 3y squared minus 6xy plus x squared. And then the rest of the terms are negative 3y squared plus 2xy plus 2x equals 0. And now I need more room, so I'm going to make more room here. Dy over dx is 3y squared minus 2xy minus 2x all over 3y squared minus 6xy plus x squared. Okay. With this result, I can now find the actual slope of the tangent at the point 1 and 2 by evaluating the slope at x equals to 1. I have dy by dx when x is equal to 1, and technically y is equal to 2 because we have y in the expression as well. So 3 times 2 squared minus 2 times 1 times 2 minus 2 times 1 over 3 times 2 squared minus 6 times 1 times 2 plus x is 1, right? 1 squared. Okay. Let's see what we've got here. 4 times 3, 12, minus 4, minus 2, 12, minus 12, plus 1. That is 6. Therefore, the slope of the tangent is 6 at the point 1 and 2.